Afternoon, everybody. My name is Ergi Pramana Jaya, and today I'm going to present our topic on factors. So let's get started. All right. In this session, we have three main learning objects. First, we will explain the concept of factor. Second, we will classify the different types of factor, and the last one, we will learn how to apply basic factor operation. Next, let's get started with the definition first. What is a vector? A vector is a quantity that has both magnitude, which means size, and direction. In diagrams, a vector is usually represented by an arrow. The tail of the arrow indicates the starting point, and the head indicates the ending point. Some common examples of vectors in physics and math are force, velocity, and displacement. For notation, if a vector starts at point A and ends at point B, we write it as vector AB with an arrow on top. To represent the magnitude or the length of this vector, we use a vertical bar, while written as the magnitude of vector B. Next. All right. Next, let's look at the different types of vectors. First, we have a negative vector. If we have a vector A, its negative vector is negative minus A. It has the exact same magnitude but points in the completely opposite direction. Second, we have the zero vector. A zero vector is a vector whose magnitude is zero, and therefore it has no specific direction on a coordinate plane. It is simply represented as a single point. And last one, we have equivalent vector. These are vectors that have the exact same magnitude and the exact same direction, even if they start at a different positions, like vectors CD, AF, and KL, shown here. All right, let's next. All right. Now, how do we write a vector in coordinate system? We can write them in two ways. First, a column vector. It's written vertically, like column vector x comma y, like this. And the second one is a row vector. It's written horizontally, like a row vector x comma y. Now, let's discuss the formulas and how to calculate them. First is magnitude of a vector. If a vector represented by vector v equals row vector x comma y, then the formula for its magnitude is the magnitude of vector f equals the square root of x squared plus y squared. For example, if vector v equals 3 comma 4, the calculation is the square root of 3 squared plus 4 squared, which equals the square root of 25, which simplifies to 5. Right? Like this. Next, factor addition. If factor A equals x sub 1, comma y sub 1, and factor B equals x sub 2, comma y sub 2, then factor A plus factor B equals open parenthesis x1 plus x2 comma y1 plus y2 close parenthesis. Next. Next is factor subtraction. Similarly, for subtraction, factor A minus factor B equals uh, x1 minus x2 comma y1 minus a y2 in parentheses. We can also look at this as factor A plus negative factor B. Next is scalar multiplication. If k is a scalar and factor phi equals x comma y, then k times factor phi equals k times x comma uh, k times y uh, in parentheses. For example, 2 times open parenthesis 3 comma 4 close parenthesis equals open parenthesis 6 comma 8 close parenthesis. Next, we get a contextual problem. To understand this better, let's solve a real world problem. Jeno walks 4 meters west and 3 meters south. What is the shorter distance from Geno's starting point to his final position? If we represent his move as a vector on a coordinate system, vector v equals a negative 3, comma, negative 4, right? To find the shorter distance, we calculate its magnitude. The magnitude of factor 3 equals the square root of 3 square plus 4 square, which equals the square root of 25, which is equals 5. Therefore, the shorter distance traveled by Geno from his starting point to his final position is 5 meters. All right. To check our understanding, here are our four exercises that we can practice. Uh, First is find the magnitude of hiker displacement factor 6, comma 8, and the second exercise is finding the total displacement factor of for a delivery driver by adding two spirit factors. Third is determining the relative position of a runner A relative to runner B using vector subtraction. And the last one is calculating a robot's total displacement after repeating the same movement 4 times using scalar multiplication. Right? Next. All right. That concludes my representation for today. Thank you so much for your time and attention. So see you in the next morning. If you have any question, feel free to ask.